That was just kill our own men. Stand down. Yeah!
Hello, in this video we will introduce the software part of drawing and shooting of the open source repeating crossbow. First, include a library that controls the servos. If you don't have a Raspberry Pi driver board, you can refer to the previous tutorial of Raspberry Pi controlling servos to let it directly control the servos. After all, drawing and shooting only need 2 servos. But pay attention to that the current of the servos may be relatively large. If you are worried about burning the Raspberry Pi, you can make a distributor blade. The GND of the servos and the Raspberry Pi should be the same. Then we include a library to control the delay time. Here we instantiate the object that controls the servos. Define the port number of the servos of both sides. These 2 direction variables are used to control the rotation direction of the servos. The rotation directions of the left and right servos are opposite, so one is 1 and the other is -1. Servo middle variable is used to set the initial angle of the servos, and the initial angle is as shown in the picture. Based on this initial angle, we add or decrease to define other positions of the servos. For example, the amplitude of the forward wiggle, backward wiggle, and the amplitude of the forward wiggle when it is discharging. Then define a time of delay. The shorter the time, the faster the reload speed. But delay too short will cause the wiggle amplitude to be too small to draw the bow. Hold function enables the servo to stay at the initial angle, and that keeps the slider still. Draw function can pass in a steps parameter, which depends on the number of teeth on the slider. The more the number of teeth, the more steps you need. Inside the function, the part of alternate movement of the servos is written by the loop for. First, the left servo is forward, and the right servo is backward. Then the left servo goes backward, and the right servo remains unchanged. And then the left remains unchanged, and the right goes forward. And finally, the left one remains unchanged, and the right one goes backward. Like this. We assume that the forward wiggle is to increase the PWM value, and the backward is to reduce the PWM value. Based on the increase or decrease of this median value, the servos can wiggle back and forth. Wiggle variable is the amplitude of the forward wiggle. Multiply the direction variable of the servo on this side to adjust the wiggle direction of the servo. Each movement requires a time for the servo to move to that position. When the number of steps is reached, the servo is kept in the initial position, waiting for the signal to be transmitted. This function allows the poles of the servos on both sides to be lifted at the same time, so that the bullets are launched. In the next video, we will introduce how to control the pen to zoom with Python multi-threading. Please subscribe and thank you for watching.